this is Mike, and welcome to BitFixer. Today we are looking again at the ROMulator Z80. For those that haven't seen it before, the ROMulator is a RAM ROM replacement device as well as a debug interface for 8-bit CPUs. In this case, it is supporting the Z80 microprocessor, whereas the original version supported a 6502. First news is that the ROMulator Z80 is now officially available. You can get it from my website. That being said, it is still fairly early in its development, so unlike the 6502 version, which has plenty of computers set up there for the default configuration available, for the Z80 version, it's a clean slate at this point. I don't really have anything in the default firmware, with the exception of this one here, TRS-80 Model 1, which is what we are going to use the ROMulator Z80 on today. We also have the expansion interface for the TRS-80 Model 1. Normally you would connect these up, and it provides extra memory for the computer as well as some other features, but today I'm only going to be using it for the power adapter. Condition of this computer is unknown, don't know if it works yet, and we'll go ahead and try it out with the ROMulator Z80. So here we go. And while I'm building this ROMulator Z80 board, I wanted to take a moment to thank PCBWAY for supporting this episode. PCBWAY is a one-stop shop for many things, including PCB manufacturing and assembly, 3D printing, CNC machining, sheet metal fabrication, and injection molding. New members get a $5 coupon that can be used on the first order. Something I really like about their assembly service is that they can supply the parts for you, or you can send them the parts yourself, which really increases the flexibility on the types of boards you can build. Thanks very much to PCBWAY. And we'll start off with cleaning the TRS-80 expansion interface here. It's fairly grimy and has some evidence of unknown creatures living within, so I don't want to speculate anymore, just clean it up. I did a test between pins 1 and 3 on the power adapter coming from the expansion unit, and it looks like we have 18.9 volts AC. And I realized later that's actually a little bit high. What we're expecting there is 15 to 17 volts AC, so oops. And then we clean up the TRS-80 Model 1 unit itself, which is similarly grimy and potentially home for unknown critters, so time to clean this one as well. And now open up the case for the TRS-80 Model 1. There are 6 long screws on the back that you have to remove. It was clear that someone had been in here before. The sticker for the warranty service had a hole in it. And then we get the top case off to reveal the keyboard. The keyboard is not screwed down or anything. It's just held in place by friction on some of these plastic posts. But there was enough resistance that I had to use a little prying bar to get some of them off. Now looking at the main board itself, there are 5 of these white rings around the plastic post that have to be removed. They are stuck on there pretty well, so you have to twist them pretty hard, and I ended up poking one of my fingers on the sharp leads on the board. Finally got the board in place, and we can look at it more carefully. Well, I'm back. I've taken care of my grievous injury here, and we can continue to look at the TRS-80 Model 1 motherboard. Over here is the Z80. These are the RAMs, presumably. And I guess this is the this ribbon cable goes around to the other side where there are some, look like there are some ROMs on there. So this is good. I'm glad it's socketed. That should be easier to test out. All right, plugged in. We have our video hooked up, ready to turn the power on. Let's hope for the best. So no video on the first power up. And what I found was that on that composite to HDMI converter, you get absolutely no picture at all. But I tried it on a real CRT. We have this monitor 3 here, and we get this right now. It looks like there's definitely something on there. It looks like maybe the sync signal is off. and then we get this. It won't really sync, but we do see that something's coming out. So I'm going to look further into what's going on. Schematics for the video section of the TRS-80 Model 1. I'm just curious about this sync signal. A potentially interesting discovery here. So we have these two lines that enter into this whole sync generation circuit here. We have H drive and V drive, and I looked through the V drive and I could see it looked like a V-sync signal making it all the way to the end here. So potentially that path is okay, but the H drive, what I'm noticing is that you see the horizontal sync get all the way up here, and then between 3 to 4 of this, I guess this is a inverter, the output of 4, we lost the signal. So I am going to try removing and replacing this 74C04 with another chip and see if that makes any difference in the display. Okay, different chip. Let's see what happens. Oh! Well, it's different. It's definitely different. Yeah, let me mess with the potentiometer, see if that does anything. So now that we have replaced the 74C04 here, the hex inverter, it appears to be improved, and this is what we get when we turn it on. So clearly this is not what it's supposed to do when it boots up. We get a bunch of, looks like 9s, kind of garbled 9s and exclamation points. So video RAM is definitely a possibility, or possibly we have bad RAM or ROM on the system as well. So next step is to get the ROMulator, replace both the RAM and the ROM, and we'll see what happens then. Hopefully we will get something on the screen. I've made 3 new settings in the table. One, we have the version 1.2 ROM for the TRS-80, version 1.3 ROM, and then the third one we have no ROM replacement to verify if that ROM is actually, the ROM on board is working or not. And you have 0 to 2FFF, that's the ROM space, so that's read-only. We have an empty region here in the memory map. 3C to 3FFF, this is video RAM on the TRS-80 Model 1. So we're not actually replacing that. And then from 4000 hex, I replaced everything all the way up to FFFF with read-write, so that's RAM on the FPGA. The TRS-80s only actually can read up to 16K there. There's probably a way to get it to recognize the rest of the memory space, but I'm not going to worry about that right now. And I also added a VRAM region, which should allow us to use a virtual display through the standalone debug adapter for the ROMulator. So let's give this a shot. Alright, first attempt. We're on setting number 5, which I set to replace ROM with the version 1.2 ROM. It replaces the entire RAM. And here we go. Let's see what happens. Okay, alright, well then we got something different. We have a line here which looks like it's attempting to print something at least. Possibly that video RAM is bad, so it's not printing what we want it to. So we can try that with the virtual display and see if we see what the CPU is actually trying to write into video RAM. So now I have the standalone debug adapter plugged into the header on the ROMulator board, and I'm over in my browser and I can connect to it, and hopefully we'll see what should be. Oh, there we go, look at that. Zoom in a little bit. It's asking us for memory size. So I believe from what I've read in the TRS-80, it's asking us for a region we want to reserve, which I don't think we want to do that, so I'll just hit enter. Oh, I'm not sure what that's about, but look at that, we have Radio Shack Level 2 Basic ready. You may have noticed that the font doesn't match the font in the character ROM on the TRS-80, and that's because I hacked up the implementation using a Commodore PET character ROM, but it's still enough to show us that the CPU is actually writing valid data into video RAM. That looks to me like I think we can tell the CPU is running and the replaced RAM and ROM is working. If we look back at the CRT here, you can see that yeah, it looks like those messages, the same messages we saw in the virtual display, are here, but the characters are different. I'm going to try to switch it now to the setting without ROM replacement so we can verify if it's actually the ROM that's the problem here. Okay, turned it off, switching to setting number 7, which is the same except no ROM replacement now. So we'll get the same, we'll get the ROMs that are connected here instead of what is on the ROMulator itself. So let's see what we got on startup now. Okay, yeah, we're back to that page with the 9 pattern there. So I would say I think it's a fairly good indication that the onboard ROM has a problem, which we have fixed by replacing it. So that's something to look into. It looks pretty clear to me that the ROMulator Z80 is working in terms of being able to replace those sections of memory so we can actually home in on what's wrong with the computer. So I enabled one additional setting here for no RAM replacement, so we actually do replace the ROM in this region, but we pass through the entire RAM segment. So this should be able to show us if the RAM on board is good or not. Now we have setting number 8, no RAM replacement, but the ROM is replaced, so it should start up. So let's try that. Okay, so that shows us that the onboard RAM is probably working. I'm just going to prove that the ROMulator is replacing the RAM. I'll take a couple of the RAM chips out and we'll run it again just to verify that it still works. Okay, I took one RAM chip out. That should be enough to prove that the RAM is either working or not working, because this will cause all the reads and writes to the CPU to be missing 1 bit, which will not work. So now that we have the RAM on the main board enabled, when we start up now, it should not start up properly, and that will verify that we're okay. Yep, we have garbage screen. It doesn't come up to that message anymore. So now we'll go back and turn it off. I'll go back and switch to RAM replacement being on, which would be setting number 5. So I'll go doops. Okay, we're back to setting number 5. And now and we still have the RAM chip missing. So now we'll start up. And there we go. So the RAM replacement appears to be working fine. Now that we've verified that all the basic functions are working, I also wanted to hook up the standalone debugger, and we can verify that the debug function is working by starting it up and downloading a memory map from the ROMulator. So we're all hooked up. Let's power on. And there you go, you see that message like we saw before. And the standalone thing has connected to my local Wi-Fi. So let's go ahead here, got a browser window. You connect to bitfixer.com/myromulator, which will relay you back to your local IP address for this. And now let's see, I'll go ahead, I'm going to try to halt the CPU. Okay, and you see the light came on the ROMulator after that, which means CPU is halted, and we can actually see on the screen, before you could actually see some of the characters moving a little bit, or little dots appearing, and now it's completely frozen, which I guess makes sense because the CPU is halted. And I'm going to read memory. This takes a few seconds, and we should get a download. Yeah, we got a download in the browser. And then I'm going to run the CPU again, and you can see that the light went off. And back on the screen, you can see some little dots appearing again. So looks like the CPU is running again. I'm going to zoom in on that so you can see the little sparkles happening. And let's take a look at that memory dump. You can see that the beginning part here is all part of the ROM. This ROM starts at 0. And let's go ahead and skip. Let's skip to the 3 3C00, which is the video RAM. You can see at the beginning here, this is actually the message written out on the screen with a question mark. This says memory size. These are indices into the character ROM, so you don't see it show up as ASCII here. And the 2 zeros are all blanks or space. I believe that's a space character in the character ROM. We go down to 3FF, and now here, this is the beginning of actual memory, and just some values in here. So it looks like the memory dump is working, and the debug functionality is working as well, which is great. So that is about it for the ROMulator Z80 with the TRS-80 Model 1. As you can see, there is still a bit of a video problem on here, which I'm hoping to resolve. It appears that the video RAM may be involved, but I didn't have any 2102 chips to spare at the moment, so couldn't really try that out any further. In addition, it looks like possibly some of the sync generation sync generation hardware still had some problems, so I will look into that further. But what we've seen today is that the ROMulator Z80 seems to work on the Model 1. CPU is running. We're able to replace RAM and ROM and debug, as well as get a virtual display using this computer. So I'm pretty satisfied with that. And a quick ROMulator announcement before you go. In addition to the Z80 and 6502 versions, you will see some other CPUs supported by the ROMulator fairly soon. Keep an eye out for a 6809 version coming soon, which is the processor used on the Tandy Coco. Thanks very much for watching. If you enjoyed the video, please feel free to subscribe or leave a like on the video. Thanks very much, and see you next time.